Hello, in this video, we're going to be talking about conditionals, specifically the hypothesis and conclusion of a conditional. So a conditional is an if-then statement, and that if part is the hypothesis thing. So that is saying, hey, if something happens, then another thing's got to happen after it. And that other thing that happens after it, that's our conclusion. If you give a mouse a cookie, then he's going to ask for a glass of milk. So hypothesis, if you give a mouse a cookie, then he's going to ask for a glass of milk is the conclusion. So let's try it out. So in this one, we want to identify the hypothesis and conclusion, single and double underline, or you could use colors like I'm going to, of the conditional statement. Then we're going to determine its truth value. So the truth value is always true or false. It's always one of those two things. So the hypothesis is just this part, so that if it rains, so if rain happens, then the conclusion is what happens afterwards. So if it rains, then the ground is wet. Yeah, when it rains, then the ground is wet. So that is true. Definitely happens. If we check the next one, we've got this. We've got like a little equation for our hypothesis. It is still our hypothesis. It's everything that comes right after that if. Then this has to be true. So if we've got this equation, x has to equal 9. Well, I don't know if that's true or not. So let's just solve it real quick. Let's see. We got 2x minus 5 equals 13. Let's see if we get 9. So I add a 5. We got 2x equals 18. Divide both sides by 2. Yeah, we got x equals 9. So this one was also true. If we hadn't gotten x equals 9, then we would have said, hey, that statement is false. Now, conditionals aren't always written real nice. So these next examples, they're not written as like kind of like clearly if thens. So what we want to do is we want to try to rewrite this thing. So we got all frogs are amphibians. So we kind of got like if frog, then amphibian. But that's not really good grammar, so let's actually make some grammar out of it. But really, this is sort of our if, that frog part, and the then is amphibian. So if, maybe we could say if an animal is a frog, that makes more sense than if frog. If an animal is a frog, then we can say the animal is an amphibian. And that's something that's true, that if you've got an amphibian, if an animal is a frog, it has to be an amphibian. So this one is also true. Frog isn't going to suddenly be like a mammal or something. All frogs are amphibians. Okay. All right. Now, this one, we've got the sum of two positive numbers is another positive number. So we've got if sum two positives, so that's kind of our hypothesis, then another positive number. So if sum two positives, then another positive number. But again, bad grammar. So let's reword this into proper grammar. So if the sum of two positive numbers, oh, wait, if, no, that doesn't make sense. If the sum of two positive numbers, that doesn't make sense either. Uh, if, let's say, two numbers are positive, this might make more sense. So then we can move. So if two numbers are positive, then the sum. So let's actually put this in our hypothesis. I think that makes more sense. If two numbers are positive, then their sum is another positive number. And that's true. A positive plus a positive is always positive. So that is going to be true as well. We haven't gotten any false statements yet, so that's cool. But you might need to rearrange the words a little bit, like this one, where we kind of needed to break up our hypothesis, or you might need to add on words if it's not making grammatical sense. When we have a conditional statement, often what we'll be interested in is what happens when we flip things around. So if we have if A, then B, to make a converse, we do if B, then A, and just see what happens when we swap those ideas around. Sometimes the truth value stays the same, and sometimes we lose the truth value of that statement. So we've got some of those same examples from before. If it rains, then the ground is wet. If we were to reverse the hypothesis and conclusion, we would take the stuff after the then, and that becomes are the. So if the ground is wet, then it rains. Uh, but that doesn't quite make grammatical sense. Then it is raining might make a little bit more sense, or it rained, whatever. Now, this one I don't think is true. This is our first false one, because there's ways for the ground to be wet when it's not raining. So the ground could be wet from a sprinkler. So from sprinkler. So somebody could have been watering the grass, and that's what made the ground wet. So then it wasn't raining. So by swapping that around, if it rains, then the ground is wet. That was true. But if you swap those around, now it is no longer true. Uh, we could do that with the next one. If an animal is a frog, then it is an amphibian. Let's swap that around. So if an animal is an amphibian, notice how it kind of brought an animal instead of if it is an amphibian, what is the it? If an animal is an amphibian. So I'm kind of swapping around this and this, swap those for more grammatical sense. Then it is a frog. I had to do a quick Google because I didn't know exactly what all the amphibians were. But there are amphibians that are not frogs. So this is also false. And so ugh. What I found was that salamanders are also amphibians, but they're not frogs. But if you don't quite know what the it's like I just need an amphibian that's not a frog. You can also say that as your kind of like why it's false is non-frog salamander. That makes sense. Okay, let's do another example. If a person lives in Minnesota, then that person lives in Columbia Heights. Now I'm going to do a little bit of switching around. So instead of that I'm going to swap these two so that this makes grammatical sense when I swap the hypothesis and conclusion. I'm going to bring the then. If a person lives in Columbia Heights, then that person lives in Minnesota. Okay, so then if we think about these two statements, our converse here, this part, that is true. Columbia Heights is in Minnesota, so that is definitely true. You live in Columbia Heights, you live in Minnesota. I live in Columbia Heights, I live in Minnesota. But there was a time where I didn't live in Columbia Heights, but I still lived in Minnesota. So you can live in Minnesota. Floss? How about false? Where you can live in Minnesota, but not in Columbia Heights. What about New Brighton? That's where I lived before Heights. You could also say just like a non Columbia Height suburb of Minnesota, but like our original statement was false, but our converse is true. All right. Last example here. If two angles are congruent, they have the same measure. So I'm going to have to do a little switch here. So I'm going to take this they and the two angles. I'm going to swap those around for grammatical sense. So if two angles have the same measure, then they are congruent. This one's cool because both of these statements are true. If two angles are congruent, they have the same measure. That's true. When they're congruent, same measure. And if two angles have the same measure, hey, they have to be congruent. So that's also true. So even though we reversed the hypothesis and the conclusion, we were able to get two true statements out of that thing. So that's cool. The last thing I want to show you is this idea of a Venn diagram. It's sort of like a diagram like this. I drew a bad Minnesota and about where Columbia Heights is. And it's a way to kind of envision what's going on with the information. If we start with our original statement we had, if a person lives in Minnesota, so they're anywhere inside of this green bubble, do they have to be in that blue dot? No, it was false because we can exist out there. Our converse had to be true because if we are in there, in that little circle, are we in the bigger Minnesota? Yeah, that was true. Our original statement, we have to be inside of Minnesota. We don't have to be in that little blue dot. But the converse, if we're in that little blue dot, we have to be in Minnesota. You can do other ones. So, like this idea of a biologist, it's a big idea of science. So, here I'm going to make a big old box for science. S-C-I-N, science. But inside of science, there's another little bubble of biologists. And an ornithologist study birds. So, like a bird watcher, they are an ornithologist. So, they like birds. And hey, bird's a type of animal. So then we could put our ornithologist like right in here. So this is our orn. So they've got to be inside of that bubble. So if we're in the blue bubble, we're in the blue bubble. Are we in the black bubble? Yes. So that's true. If we check our converse of if bio, then orn, that doesn't make sense because we could be, so if we're in biologists, if we're like out here, we don't have to be in this blue circle. We might be, but we're not quite there. So this one is false because we could be out in this area. And that's it for this idea of conditionals and converses. Converses, the idea is that you just swap what's going on your original if then, you make it then if, but you keep the places of if and then. Make sure that your sentences make grammatical sense, so you might need to move around some numbers to fix that. Thanks for watching. Bye bye.